So we have a lot of batteries left from the connecting 1,000 batteries in series video, and we could definitely make much higher voltage with 9-volt batteries, and 9-volt batteries could also deliver much higher current. So what would happen if you connect over 100 9-volt batteries in series? Where are my safety glasses? Found them. Well, it's not any dangerous yet, but we're definitely going to be dealing with some high voltage soon. So that's why I'm getting the glasses. Alright, with all of the preparations out of the way, I began connecting all the batteries in series. And if you don't know what happens if you connect batteries in series, you really just multiply the voltage. And we all know that a 9-volt battery have 9 volts. And I got 108 of them. And 108 times 9 volts equals to 972 volts. So I really gotta be really careful with this. But I'm not expecting to get the full 936 volts, because these are used batteries, so I'm not expecting all of them to be fully charged and have exactly 9 volts. Yeah, that's it. Okay, so we got 108 9-volt batteries. So we're actually not getting more voltage. So that would be roughly 945. Is that correct? No. 981. No, you don't get 981 volts. When you time 9 volts times 108, you get 972. My calculations sometimes are so just way off. Ugh. Okay, we have 108 9-volt batteries. Let's see how much we actually got. Okay, this is minus, and this is plus. Oh wow, that's worse than I thought. We are missing like 100 volts. 894. So I'm gonna connect up these so we could. I know that those 2 points are the most dangerous, but I'm still gonna get my 1000 volts gloves. 1000-volt gloves, yeah. It's like washing gloves for doing your dishes, but this is no dishes. And I should also mention that you shouldn't do this at home unless you know what you're doing. I kind of know what I'm doing. Yeah, you shouldn't really play with electricity, but yeah, 895. Okay. Well, I'm gonna move the GoPro so you can see the. Whoa! Almost broke my shelf there. Well, I did. I did break my shelf. Whoops. It's really bad craftsmanship because I didn't have those steel angles like these left when I made this shelf. So yeah, it's poorly made. Whoops. So yeah, the voltage. Actually, before we short them, because I want to save some of the current, I want to try to make hydrogen with this. So I'm gonna mix up some. What's it called again? This stuff I made to make the hydrogen generator. It's in this container. I forget the name of that chemical I used. Yes, I'm gonna keep in mind that we have live electrodes on the table, but that's fine. Okay, so I used. Oh boy, what's that in English? Calcium hydroxide? Is that correct? Calcium hydroxide. It's in Norwegian, but yeah, this stuff. And the reason why you use this stuff is to make the water conductive, to make the electrons pass through the liquid. What's really happening is that you break apart water molecules into hydrogen and oxygen, and that makes an explosive gas. Okay, well, I don't need the gloves for this, but okay, I'm gonna put the gloves over these, just in case. Yeah, we could put this one on the shelf again. Made broken shelf. Okay. Whoa, it's been a while since I made hydrogen. It's like 2 years at this point. It was one of the first projects I made in this channel. I really want to make another one, but I haven't found time yet. I forgot the mixture, how much I should mix of both. I think it was 4 grams per 100 milliliter. Maybe I should check that out. Okay, so what do you search on? Hydrogen generator, liquid mixture? I don't know. Hydrogen generator, calcium hydroxide mixture rate. Yeah. Okay, so 18 grams per 200 milliliters. So I was off. I said 4 grams per 100 milliliter, but it's 18 grams per, or 9 grams per 100 milliliter. So how much would this be? Okay, so this is 600 milliliter. That would be 54 grams of hydrogen. Why do I keep saying hydrogen peroxide? It's calcium hydroxide. And, well, we could just use this container. That works. And then I need a scale. Oh, it's so much stuff here. Ah, there it is. Yeah. Okay, I said 54 grams. That's right. Okay, so that would be basically 9 times 6. Okay, so calcium hydroxide is something you wouldn't want to have on your fingers or drink and get in your eyes, get in your skin, and all that kind of stuff. So, well, these are not waterproof gloves, but I'm gonna be careful. So don't you worry. 54. Okay, whoops, 63. So it's gonna be a little bit stronger mixture than it should, but just a small experiment. So yeah, it's fine. Completely fine. Nothing bad should happen now. So many people may call me an amateur when it comes to chemistry. And yeah, you're completely right. I have no education in this stuff. So, oh, something was hissing or making that electricity sound. It's just on the bottom of this stuff. But yeah, what I was about to say, if you see me doing something wrong, you're probably right. So yeah, comment it down below, since I'd like to learn what I'm doing wrong. Definitely everything is a learning experience at this point. Okay, I'm gonna wait for the water to clear up, so we may see some of the bubbles getting created. And also, if I remember this correctly, a hydrogen cell is supposed to have 2 volts in it. We're using 900 volts. So, well, that's why you experiment, to see what's gonna happen. I'm very conscious about my hearing, so I don't want to, just in case something blows, I'm gonna protect it. Well. Okay, I'm gonna turn up the lights. Probably easier to see. Oh, that's so cool. And yeah, we're actually getting bubbles, so we're producing hydrogen and oxygen, of course. But they're really small, so I don't know if you can see them on camera. When I was making the first hydrogen generator, it's such a hard word to say, hydrogen generator. Anyway, when I was making that first generator, I didn't wear any hearing aid, and I did a test, and man, it was loud. So yeah, I'm gonna try to protect my hearing as good as I can. So yeah, those bubbles, if you could see them. The water is hot and it's bubbling. Huh, can you see that? Could someone explain this to me, why we're making bubbles without having a closed circuit? There's no way that this electrode can pass any current through me, because I'm very highly isolated. And still, what's going on here? It's probably going to make a whole lot more bubbles when I put down the electrode. Yeah, that's a lot more. Whoa. Well, it was kind of expected that we would produce some bubbles, but I still don't understand why we're producing bubbles with only one electrode in it. So if any smart guys are watching this, could you please explain this? Never seen it before. Unless it's some process that's breaking down the metal. But what we could do is try to disconnect the minus and see if we're still making bubbles. Yeah, we are. So it's probably some process going on where we're breaking down the metal. And that goes way above my knowledge because I didn't study chemistry. But that's probably part of it. Yeah. So it's most likely not going to be much more than a small arc. Well, it's a bigger arc than we made with the batteries. That was like, we could only make it like, I guess, a millimeter. But this one stretches much more. But I'm guessing we're getting this more stable arc because we have much more current to pass through. Or we have more current to draw from the nylon batteries compared to the AA batteries. Even though we had higher voltage than this, because the batteries we measured 1400. Here we have like 900, I mean. But we're having much better arc, like this. Yeah, not like this. It's disconnected. Well, this experiment was much more fun than the AA batteries. That took me like 3 weeks. This, much easier. It would be fun to have more 9V batteries, but probably would be more interesting rather than getting a bigger arc. But as many people have said in my last video, or in the battery video, you can make arcs with a lot of other methods than this. Yeah, I was gonna show you this. Woo. Yeah, so I guess that's what happens when you connect a lot of 9V batteries together. And yeah, let me know if you want to see more cool experiments. I don't know if this was even cool, but I think it was. Yeah, if anyone knows why it started bubbling or what kind of chemical process that happened when it started bubbling without any electricity, or kind of what process happened, let me know. It would be cool to know. So, but other than that, thank you for watching and see you in the next one. I really don't know how to end videos. What do you say? Like and subscribe. Well, end.